Good morning, everyone. I am Dinesh Lakawat from the IT department, section A. Today, I am going to talk about the subject object-oriented programming. So, let us come into the topic optimal account balancing. Introduction to optimal account balancing. Optimal account balancing aims to allocate financial resources efficiently across accounts. It helps minimize costs and maximize financial stability. This presentation explores categories and mathematical models to achieve optimal balance. Now, let us talk about the importance of account balancing. Proper balancing ensures liquidity and prevents overdrafts. It reduces unnecessary transaction costs and penalties. Effective balancing supports stability's financial decision makings. These are the three importance of account balancing. Key concepts in account balancing. Accounts should be balanced considering both current and future needs. Balancing involves managing cash inflows and outflows efficiently. The goal is to maintain optimal account levels at all times. Challenges in account balancing. Unpredictable cash flows can complicate balancing efforts. External factors like market volatility impact account management. Manual balancing is often time consuming and prone to errors. Mathematical foundations of optimization. Optimization models use mathematical techniques to find the best solutions. Linear programming is commonly applied to the balance constraints. These models help identify optimal transfer amount and timings. Formulating the optimization problems. The problem involves minimizing costs or maximizing utility subject to the constraints. Variables typically include transfer amounts between the account to the another account. Constraints include account limits, transaction costs, and timings. Cost functions in balancing. Cost functions quantify the expenses associated with transfers and balances. They include transaction fees, penalties, and the opportunity costs. Minimizing the cost function leads to optimal balancing categories. Constraints in the model. Account balance constraints ensure accounts stay within specified limits. Cash flow constraints account for incoming and outgoing funds. Temporal constraints consider the timing of transactions. Common optimization techniques. There are three common optimization techniques: linear programming, integer programming, and heuristic algorithms. Linear programming efficiently solves many account balancing problems. Integer programming is used to transfer. Heuristic algorithms provide approximate solutions for complex scenarios. Now, difference between dynamic and static balancing. Static balancing considers a snapshot of accounts at a fixed point. Dynamic balancing adjusts or multiple periods considering future cash flows. Dynamic models typically yield more resilient and cost-efficient solutions. Implementing optimal balancing categories. Data collection and accurate forecasting are essential. Optimization modules can be implemented using software tools like Excel or specified solvers. Regular reviews and adjustment improve long-term balancing efficiency. Case study. Corporate cash management. A corporation adjusts intra-company transfers to optimize cash levels. The model minimizes transactions costs while maintaining liquidity. Results show significant cost savings and improved cash utilization. Benefits of optimal account balancing reduces operational costs associated with unnecessary transactions, enhances financial stability and reduces risk exposures, supports strategic planning and resource allocation. Now we talk about some limitations and risks. Models rely on accurate data and assumptions, which may not also hold. External shocks can disrupt optimal plans. Over reliance on models may reduce flexibility in decision making. Advances in technology and tools. Machine learning enhances forecasting accuracy for cash flows. Automated optimization tools enable real-time balancing. Integration with braking system streamlines transaction processing. These are the some advances technology came into the world. Best practices for effective balancing. Maintain accurate and timely financial data. Continuously update models with new information. Use scenario analysis to prepare for uncertainties. Future trends in account balancing. Increased use of AI and predictive analytics. Greater emphasis on automation and real-time adjustments. Development of more sophisticated multi-period models. Summary and key takeaways. Optimal account balancing minimizes costs and enhances stability. Mathematical models are essential tools in designing balancing strategies. Ongoing monitoring and adoption are crucial for sustained success. Summary and key takeaways. Optimal account balancing minimizes cost and enhances stability. Mathematical models are essential tools in designing balancing strategies. Ongoing monitoring and adoption are crucial for sustained success. Resources and further reading. Explore books on financial optimization and cash management. Utilize software tools like Excel, Slower, Burovi, or Ciplex. Follow industry updates on fintech innovations in account balancing. Resources and further reading. Explore books on financial optimization and cash management. Utilize software tools like Excel, Slower, Burovi, or Ciplex. Follow industry updates on fintech innovations in account balancing. These are the some resources and further readings. Conclusion. Now we conclude this topic. Effective account balancing is vital for financial health and efficiency. Combining mathematical models with technology leads to optimal solutions. Now let us conclude this topic. Effective account balancing is vital for financial health and efficiency. Combining mathematical models with technology leads to optimal solutions. Thank you for your patience and thank you for your attention. I am happy to answer any questions if you have any doubts. With this, I am closing my section. Thank you for listening.